In class, we had a lecture on 5.4, but I didn't have my tablet loaded with the account. So we're going to go over this again and discuss how we're going to get to the fundamental theorem of calculus. That's the key here, the fundamental theorem of calculus. The book started with the mean value theorem for definite integrals. And it says some function of c, of x equals c, is equal to the average 1 over b minus a of a definite integral from a to b f of x dx. So this is the structure that affords us the average, uh, of the area under the curve. And we did this for curves that were positive, okay? And we're going to talk about that as we continue on our studies. So then it brought about, from this, we get this, the fundamental theorem of calculus. It says if f is continuous over AB, the domain of A to B, then cap f of x equals the integral of a to x for f of t dt is continuous on a, b, and differentiable on any part interior of a, b, and its derivative is f of x. Okay, so the integral is that f of x. All right, so that states that cap f prime of x equals the small change, the derivative d over dx of the integral a to x f of t dt is equal to that function, that original function, f of x. So we're saying this for that interval. All right, so we get an example here. So let's do a few examples. Maybe we'll clear up. But you notice we don't have t anywhere in the process, but we just have normal evaluate the integral. So on this integral, from 0 to 1 of the 5x squared minus 8x plus 8 dx, that's that small change, then I'm going to have the 5x to the 3 divided by 3 minus 8x to the 2 divided by 2 plus the 8x from 0 to 1. I'm going to clean it up. 5/3 x cubed minus 4x squared plus 8x from 0 to 1. All right, so when I do the integration, I'll have the 5/3 times the 1 cubed minus the 4 times the 1 squared plus 8 times 1. All right, for the first part. When I do this math, I'm going to get the 5/3 minus the 4 plus the 8. All right. When I do this math, I'm going to get, and I can do it all on the calculator, and I am on this particular unit, so I don't make a mistake. 5 divided by 3 minus the 4 plus the 8. And I get a fraction of 17/3. So we have this. Now, it didn't say it was area under a curve. It didn't say anything. All it said was do the integration. And what we have here is our cap f prime of x. So now let's do this integral. And I'm going to rewrite it. And now I'm going to take the antiderivative of it. All right, from 0 to 1. Again, 0 in anything is going to be 0 as we get the x's there. So I'm going to rewrite it. We're dividing by the 3/2, so that's a reciprocal. And now we're going to apply our answers. So I'm going to have a 1/3 plus 2/3 minus 0 plus 0 for the bottom part. So this gives us 3/3, which gives us 1 for that value. And again, because we're discussing this as not area, but as the integral of x, but in terms of t, time, some kind of movement. So here we have our trig. And we're going to look at the 9 on the outside because it's a multiplier. So we have this. And we look on the information sheet on the derivative of secant squared, and we get tan x. From 0 to pi fourths. So I'm going to have the 9 and the tan of pi fourths minus the tan of 0. And we're going to multiply the answer by 9. So this is 1 plus 0. Because at radian 0, we have 1, 0. So the tan of radian 0 is 0 over 1, which is 0. So we get 9. 9. Okay. Well, now we have sine of 2x. And sine of 2x, we have a formula that says if I have sine of kx, the general antiderivative is 1 over k, which is a coefficient of the variable, cosine of kx, and that's what we're going to use. Because it's negative, because this is, remember, we started with something like this to get this. So I'm going to do negative, and it's 1 over 2, because that's a coefficient of x, cosine of 2x for the value 0 and pi eighths. So I'm going to have a multiplier. Oops, I'll put a 3 and it's a 2 of cosine of 2 times pi eighths minus cosine of 2 times 0. All right, so I'm going to have a negative 2 cosine of pi fourths, because I'm going to reduce that right there, minus cosine of 0. Now I'm going to do the math from 0. I'm sorry, now I'm going to do the math. Sorry about that. All right, so let's do that math. Cosine of a pi fourths is a square root of 2 over 2. And minus the cosine of 0 is 1. And we want to make the negative 1/2 of it. All right, so it's easiest to first do this math. Negative 1/2, and it's a 2. So it's going to be the square root of 2 minus 2 all over 2. So now I can get my answer easily. A negative square root of 2 over 4 plus 2. Now we could rewrite this, which would make it elegant in mathematics, to read 2 minus the square root of 2 over 4. And we can't reduce that. All right. Well, here we have an e. And e is very interesting because we know e dx of e to the u is e to the u of that exponent. So in this case, we're talking about having ended up with a 2. All right, because we're going to be dividing by it. Okay, so, and it's from 0 to ln 5. Okay, here we go. So I'm going to have a 2 multiplier, and that gives me e to the 2x dx. Now remember, I'm going to have this as an output. Okay, so I should have had a 2 du, and I do. So then we end up with e to the 2x from 0 ln of 5. Because if I ended up with 2e to the 2x, then I did take the derivative because I would have divided by 2. All right, so then I'm going to insert it. Okay, well, this is interesting because we're going to use the rules of logarithms, which means I can do an exponential. Now we know any number to the 0 is 1, and these are inverses of each other, so I have 25. So my outcome is 24. All right, we have to think about this particular rule to end up with what we have. And in this case, we have the du of u is going to be the 2, and that's what I had. So that was a pretty easy one. Now it talks about total area. In total area of a region between x-axis and the graph of y, negative equals negative x squared minus 3x for the domain of negative 8 and 3. Okay, so our first step is to graph it. Because we know it's an upside down something. All right, so I didn't change my window and it worked out pretty nice. So we have some critical numbers and we have area here. Let me take a picture of that. All right, so this is what we have. We have from negative 8, 1, 2, 3, 4, 5, 6, 7. Oh, 8 is right there. So we have this area here, this area here, bounded by the x-axis, and this area 2, 2 is this area here. So this is negative area and negative area and positive area. But the problem with this guy is that we have half a area there, and it might be 0. So we have to be careful with that. So we have 3 integrations on this one. So we're doing the addition property of integrals. Okay, so I'm going to say from our start, -8, and our critical number here is -1, 2, 3. And it looks like -3, doesn't it? Well, how would I get that if I didn't know it? Well, we would set 0 equal to -x² minus 3x. I would factor out a -x and get x minus 3. Set them to 0, so this one's 0 and this one is a positive 3. I'm sorry, this is a -3. Sorry about that. So my critical numbers are -3 and 0. So I'm going to have, and remember, it's going to come out negative, but we're going to consider it a positive. Or we can reverse the values to get it in a positive mode of, and now we're going to put we're going to add to it the integral from -3. Now this one, I'm just letting you know that if we do it, we have to double it. So we want the center. So it is -3 plus the 0 divided by 2. So it's a -1/2, 1 1/2. All right. So we can do it that way and double it, but let's go ahead and try the 0 and see if it comes out okay. And that is and these are dx's. And then we have the last one. And I'm going to have to erase this so I can make it all cohesive. Zero to 3. All right, of that function. Okay, so let's see what we get. I'm going to have a -1/3 x cubed minus 3/2 x squared. And then this one's going to be the same. But it's from -3 to 0. And then we have the last one. All right, so let's see what we can do with this. Okay, again, we're going to look and do the math. So, and I'm going to do it on the calculator. A -1/3 times -3 cubed minus 3/2 times negative 3 squared minus a negative 1/3 times negative 8 cubed. This is with this. Minus 3/2 times a negative 8 squared. All right, so this is that first one. So let's do it on our calculator. Oh, and we have a feature. Watch this. We can go, on the graph. We can tell it to calculate let's see, do I have it on this one? The integral, number 7. And we can state negative 8 to, that's the lower, and the upper is negative 3. Amount of it, negative 79, and I think that's a ninth of some form. Okay, and then you can do the second part, and let's do the second part. So we're going to do second calc, and we're going to do number 7. Well, I'm thinking about it because I didn't do it in class. Negative 3 is the lower, and the upper is 0. And it gave us 4.5. And then the last one is from the lower. Let's see if I can do it without having to hit the program. I'm not sure. 0 no. Okay, let's go on that one. Now I can do it from here, from 0 to 3. And oops, let me look at what I did. Oh, I must have entered. Oh, sorry. 0 is the lower, and upper is 3. Didn't take it. Why didn't it take it? I don't know what I'm entering. Let me do it again because it's driving me nuts. 0. Oh, it did it. 2, 3. Invalid. Huh. Okay. Well, we would have gotten it. I don't know what I hit wrong, but you can try it. It's always fun to do that, and I guess it only takes 2 at a time. Is probably what it is. So it'll measure all the area for this function. All right, but back to our problem. We want to go on the home screen, and we want to do some math. So I had a negative 1 divided by 3 times, in parentheses, a negative 3 cubed minus 3 divided by 2 times, and I'm just going to put 9 because that's what that is. And I get a negative 13.5, it looks like. That's what I got. I'm going to do the second part of it. And this is minus. And I'm going to have, I'm going to just do the problem and do the minus at the end. Negative 1 divided by 3. Hopefully I didn't do a problem here. Parenthesis, negative 8, parenthesis, up caret 3, minus 3 divided by 2 times 9. I'm sorry, 64. All right, and that was at 74 and 2/3 that we saw. I'm just going to put 2/3 because I have a half and 2/3. All right, So I have this guy right here, and and this was positive, so it's a negative. So the whole thing is a negative that, and that's bigger than what they showed on this one. I thought it was a 70. Let's do it again. Let me look. It's always my math. It's never anything but my math. All right. So let me go back here. Oops, on the Y. And um, let's just clear it. Okay. Okay. All right. I forgot how to clear that. I'll look that up. Let me do it again. Second calc, number 7. Lower bound is -8. Upper bound was 3. I got 79, and it was negative 79.16 forever. All right. And this in the middle, I got 4.5. So what I want to do next is second calc 7, and I want to do 0 to 3. It still says it's invalid. Let me look at my window. Maybe my window's wrong. Oh, I have it on 2. That's why it wouldn't work. Okay. That's why. I was saying, what is wrong? So second calc, number 7, 0 to 3. And then I get -22.5. All right, so I'm going to look at my math here, and I'm going to do it so I can match. Okay, guys. Sorry, my math stinks. Okay, so I have a -1/3 times, and this is a positive, negative as well. It's going to make it a positive. So this is 27 negative. 3 times 3 times 3. Minus 3/2, and this is a positive 9. All right, so if I do this guy, this is going to be a positive 9, and this is going to be minus 27/2. All right, and that'll give me, okay, let's do the calculator here. 9 minus 27/2. -4.5. All right, now we're going to minus, and we're going to do this next one. So this is 8, and oh, that's where I made the mistake. Oh my God, that's where I did it. Okay, I have a -1/3, and I want 8 cubed, which is a big number, 512, and it's a negative. Minus, and this guy, I had it right, was 64. So go in there, won't it? 5, 6, yep. So I'm going to have a positive, and I'm dividing by 3. Oh, it's not. I said 6. Oh, it's an 8. Oh, it's 170. I'm going to just take it. 170 and 2/3 minus, and this is 32, and that would make it 96. And there it is, 74 2/3. And this is in negative because of this guy. All right, all right. So we have that. That's a negative, so that makes it 79 and let's see, 2/3, that's 15. Oh, it's 15ths. Okay. Yep, that's what it is. 1/2 plus that is 1, and it's going to be close to what we got in there. Understand that the calculator does have some parameters that we're not going to be exact, but close enough if we rounded. So we're going to put here, it's going to be 79 because I added the 1 over, and that's 15th, isn't it? No, it's more than that. Okay, so it's going to be, what is it going to be? 15. Seven sixes. All right. There it is. And that's what we had on our list. And then we were going to do one, the math. I just did the math wrong. Doggone it. And then the next one is 4.5, and we're going to do it by the rule. So I'm going to have a negative 1/3 x cubed minus the 3/2 x squared from -3 to 0. And when I do that, well, I get 0 for the first group minus, and then I'm going to have a negative 1/3 times a -3 cubed minus a 2/3 times, and that's going to be a 9. This is going to be a positive. This is 27. 3 to the 3 is 27. That's -9. And this is going to be minus, and this is 3, 6. Okay. And this one's a positive. I'm sorry. And that's going to give me a 3. And it said 4.5. And that's close enough. But I did the math right on that guy. And then I'm going to have the -3. And that one's going to be from the 0 to the 3. And we're going to get the same number up here, but reversed. And it's 27, yes. And this is 9, yes, yes. So we're going to get the same answer. It doesn't matter because we're doing only the positives. So we had the 79 and the 6 for these two, and we had a 2/3. Approximately, this is the area. All right. I'm going to stop there because I've been talking too much.